Let's make a shop or shed, because why not? All right, getting right into it. That is my perimeters you just saw, and we should go back to them in a minute, I believe, on this first part one video. You don't have to use parametric modeling. Again, I just find it to be helpful, and I think on this one I ended up not really using it to its full extent. I just didn't see the need for it because this was going to be a one-off. This was not going to be something that I needed to make several different types. But say you want to make some templates or drawings for people, you can do this with parametric modeling. And that way, if someone wants a 12 by 12 or 12 by 20 in lieu of a 10 by 10, 10 by 12, then you can easily adjust the parameters to change everything on the drawing. But anyway, moving right into it, I do have a perimeter set for concrete blocks for this one. I am not going to draw in. You can do like skids, 4x4 skids if you want, or you could pour a slab. I just, in my mind, would envision this having just some patio concrete blocks for this to set on. So that's why you're not really seeing anything but the 2x6 base banding right here. So anyway, and you're going to want to use treated wood on this, if you're wondering. And because you can see on the left there, I'm actually spelling out the types of material. And the reason I'm doing that is because whenever you go to print the drawings for this, and when you print out the material list, which it will do as well, obviously, in Fusion 360, you're going to want to know what that material was. Otherwise, it'll just say pier, or it'll just say band, floor band, instead of 2x6. So you ideally want to do that ahead. You can always change that later. It's not a big deal if you're in a rush. You can just shoot out components. As long as everything is a component and not a body, you'll be fine. But anyway, this is kind of how I start off doing a shop or shed design. I start obviously with the bottom foundation for it, the floor joist, and move forward on it. Again, you're going to want to use your offset and midplanes through the construction tab, which you will see me do in just a second here. That way you can easily mirror any of the material. And as you've seen before in my videos, when you mirror, as you'll see now as well, the component that was mirrored will simply show up as a mirror of the other item, as it should, and there you have it, and you'll see it on the material list the same way. That way you don't have to go back and name 60 joists. They'll individually populate on their own in Fusion 360 whenever you use the mirroring function, or when you do the pattern on path, pattern on rectangle, same thing, which is what you're seeing here. And again, I don't do pattern on path unless I'm doing leatherworking. It's just a different technique that works better in leatherworking. In woodworking, I use the rectangular pattern. And again, you just pick, as you saw, you pick the direction, and then you start picking the quantities that you feel you will need based on either spacing. In this case, I believe I was going to go with 16-inch on center, or you could do extend. Now, you'll see in a minute here, I'm going to switch over to extend in lieu of the spacing. And that just gives you the capability of adjusting or tweaking what you did. So I have 16 on center, but when I switch over to extent, I'm going to be able to manipulate where these are a little bit easier. The problem with that is you're going to lose in this carpentry, you're going to lose the 16-inch on center. So I think what I decided to do here is just add an entirely new 2x6 floor joist because I was starting to lose my 16-inch on center. Yeah, and I guess I clipped that part of the video out, but I did go back and add that additional floor joist there at the end so I could maintain the 16-inch on center, which is not a big deal. I just wanted to get the quantity of lumber at the end where it needed to be, so I didn't want to be short 2x6s on this build, so I added one in there so that I would have the spacing that I needed no matter what. So right here, I'm obviously putting in the subfloor, which is the 3/4 inch tongue and groove. And I believe I even spell out, yeah, tongue and groove. Again, like I said earlier, you're really going to want to spell out the material. That way you know, or the customer knows, if you print off the material list and or drawings at the end, they're going to know that they need to get Okay, for this, obviously you're not going to be able to get the full amount of 4x8s to span the entire floor joist here, which is what you're seeing. So what you're going to want to do is get at least the coverage you need. That way, whenever the component is created on the left, you'll know that you still need to get an extra piece of 4x8 tongue and groove for that portion of the build. Okay, once the subfloor is complete, you're going to want to start working on the wall studs. And I did have a parametric setting for the studs, but I don't know that I stuck with it. Um, I believe I went with 8-foot high walls on this one, but I ended up, as you will see, I was going to go with a like a lean-to type shed because it's just a lot simpler in the field building it and designing it because you don't have to deal with a lot of the roofing, which can be a little tricky. But I went on for this video and made it a little bit more complicated and went with the pitched roof to where you could apply composite shingles in lieu of maybe like a R panel roof on it. And it's just more knowledge using Fusion 360 when you do the more complicated type of roof. So I'm laying out the studs here. You need to make sure that you are touching the top of the tongue and groove floor here, subfloor, because if you remove the components and hide them and you work off the bottom sketch, obviously your stud is going to start at the bottom underneath where the 2x6s are, the floor joists, and you're not going to want that. You want it to start on top. So, and something I didn't do here, which I didn't catch until later, is you actually need to put down a 2x4 bottom plate along the perimeter walls and then put the studs on top. I would probably go back on this one and add those in if I would. Well, I would for sure if I was going to be selling this as or giving this to someone even to use to build their own shed, because they need to know that you need to have the bottom plate, which is the horizontal 2x4 along the bottom of the wall studs, as well as the top, which I did add the top header top plate. But if you don't have the bottom plate, it's kind of pointless. So anyway, for those that watch this and see that I don't have that, I do know that. I just, given the amount of time to get these videos out, I wanted to go in and keep moving forward and not go back and edit that particular item. But anyway, so you can use, as you can see here, a rectangle on path to get these quickly out to the distance you want. And then once you're done using the spacing feature on rectangle path, you can switch it over to extent and tweak these around. Or you can individually click on, like I just did, the very last stud there, right click if you're using a mouse, and click while holding that component, and then simply click to move it and move it in place to where you want it to sit. So a lot of different ways to do that in Fusion 360. what I'm doing here is just adding in where my window will go. This is also going to be a good education for those wanting to learn. I'm assuming if you're watching this Fusion 360 to do something like this, because if you remember, as you can see there, all of these were essentially mirrored or copied, so they all changed when I did my cut through for the window, which is exactly what you do not want because they're all tied together. Now, there probably is a way to isolate the components that you want to work with. I don't remember how to do it, to be honest, and I don't know if I've had to use it lately. For sure I have not. So there is another workaround that you can do, which I think it's kind of how I learned how to do it, and I think it's what a lot of people end up doing anyway, so I don't think there's a quicker fix in Fusion 360 that I know of to do this. But you basically have to go in here and copy the studs, in this case, where the window is going to be, and create new ones, and then go back and hide the ones you don't need whenever you perform the cut. That way it isolates them a different way, so that you can make the openings, the window and the door in this case, on this particular build. So once that part is done, I know it's a lot. It's kind of a pain in the butt to use this technique, but again, I don't remember another way to do it. So this is how I did it, and you can go back and add more vertical studs in, which you're going to want to do for the support and jack studs and everything else, which I will show you, I believe, in part 2. I will finish off the window and add in the door and start working on the remaining framing, getting ready to put the roof on. And just so you know, too, I will show you how I do hardy plank siding. I actually added that onto this one in lieu of doing like a plywood wall on the outside and painting it or something basic and boring. I added hardy plank, so you'll see that lap siding as well up on a future video on this build. And thanks again for watching, and leave a comment if you have any questions or if I'm doing something wrong or have a tip. I'm by no means a master pro at Fusion 360, so I'm willing to learn anything I can on this as well. Thank you.